Hello, hello. Uh, Sorry, I got a bit late. I was making this sandwich, as you can see. So, if I remember correctly, we've seen up to this in the data types. Now we have to see the collections part. So, let's not make any delays. We will have to finish much parts. Yeah, we have to go to day three content. So, let's just jump right in where we left off. So, as you can see, collections are data types that can store a set of data, a collection of data. So we always don't have a single data to store, right? For example, if you're in a class, you don't have one single student's name. You will have 50 students. So instead of assigning 50 variables to 50 students, what you can do, we can collect all those names and then using a collection, which I'll be telling, you can keep them in a particular, sorry, you can keep them in a particular collection according to your needs and then assign that whole collection to a single variable. Okay, so let's see. The first step is list, the most popular one. Just a second, guys. So, mhm. Just give me 1 second to set this thing up, and then we can start with the list. Okay. So lists are used, as I said, for storing multiple variables within a single, multiple items within a single variable. So they are ordered, they can be changed. So they are ordered, they can be changed and are allowed to contain duplicate values. So what does a ordered list mean? So these three things are very important in collections: ordered, changeability, and duplicate values. So when they're ordered, it means the items have a definite order and that order is not changed. Basically, each item has a specific index. So when new items are added, unless specified, they are placed at the end. So now this indexing leads to duplicate values. How? Suppose you are in a class. My name is very common. My name is Anurag, and you have to store the names of the students. So there were four Anurags in my class. So you cannot just say that yeah, Anurag is there. You have to mention which Anurag. So there the indexing comes in. If I say myself as Anurag 0, my friends as Anurag 1, Anurag 2, and Anurag 3, then you can say that, yeah, I want to meet Anurag 1. So you'll meet one of my friends. If you say I want to meet Anurag 2, you will meet another of my friends. If you say Anurag 0, you will meet me. So this 0, 1, 2, this basically acts as an indexing, right? That's why, since lists are indexed, they can have duplicate values. They're considered mutable. So mutability and immutability is a very important thing. If something is mutable, that item can be changed, added, or removed after the creation of the list. If something is immutable, the items cannot be changed, edited, or removed. Okay, after the creation. During the creation, it's okay. During the creation, you have full freedom. But after creation, mutability means after creation, you cannot change, edit, or anything like that. Let's see how a list is made and how to get the length of the items in the list. So I have a list called fruits. You just specify a list by using third brackets, and then you separate the item using commas. So this is the most basic form of describing a list. The another thing you can do is using the list keyword. So if you say list and then in brackets you specify the items, you will get the list. So as I've run this already, I'll just show you. Just give me a second. Jupyter is starting. Yeah. So this list is fruits. This gives you apple, banana, and cherry. It has a length of 3. This list is a different list which is constructed using the list constructor. This gives you mango, orange, and grape, as you can see. And list is always printed with the third bracket in this format, a third bracket, and the elements are separated by commas. Now, similar to strings, the indexing and list is very similar to strings, and you can access an item similar to strings, just similar to strings. So negative indexing is also allowed. You can also access items using negative indexing. Slicing is also there. Accessing a single item is also there. In strings, we access characters. In list, we access items. So let's just see. Okay, just give me a second. Let me just run this whole thing real quick. Okay. Mhm. So see, we can have normal indexing. Let's just print the fruits first. Print original list, original list, original list. Let's go fruits. See, normal indexing, if you go fruits, zeroth item, that means the first item. It's apple. Second item, you mark as 1. What you get? Banana. When you say negative 1, it's the last item. So in negative 1, you get cherry because it's apple, banana, and cherry. In negative 2, you get banana. You say 1 is to 3, that means from the 1th index till the 2th index because 3 minus 1. So you get banana and cherry. Minus 3 is to minus 1. Similar to strings, you get apple and banana. How to check if the item is existing in the list? You just have to mention the item, use the in keyword, and then mention the list. So apple in fruits. Let's see, is apple in fruits? Yeah, true. Kiwi in fruits? Is there kiwi in fruits? Because we have only apple, banana, and cherry. So it gives you a false. Now, how to change the items? Mutability. This is the most important part of a string. How to change the items? So let's go ahead and see how to change the item by specific index. So if we say fruits of, let me just increase the brightness so you can see it better. If we say fruits of 1, that means, let me just print again the original list. Hmm, print original list is fruits. Yeah. Mhm. Okay, this has run already. Um, you cannot do anything with this. But as you see, the original list is apple, banana, and cherry. So I'll just print this if you want. This was our original list. List original equal to this, and now we print list original. So as you can see, wait, what? Okay. So original list is apple, banana, and cherry. The first item, okay, this is access items. Not this, not this, not this. Okay, I may have made some mistakes. Let me just copy paste this in the next code block. And this is fruits. Yes, this is fruits. This is the comes. This is just right. So apple, banana, and cherry is there, and we need to change one first index to blueberry. So this is the first index. Now it will become apple, blueberry, and then cherry. Okay, there is an issue. Let me just clear it. Since all these functions are running, it's changing the list. So I'll just make them into separate sections so that you can actually see what is happening. See, the original list is apple, banana, and cherry. But after the change in index, after you change the first index to blueberry, it becomes apple, blueberry, and cherry. Now, you can change multiple items also. So if we give 0 to 2 is kiwi and melon, so apple and blueberry, because 0th and first index, these two will be changed. So apple and blueberry will be changed, and we will have kiwi, melon, and cherry. So let's check this out. See, kiwi, melon, and cherry. Now we have this function insert and append. So difference between insert and append is when you append something, it is automatically added to the end of the list. But when you insert something, you can give at which position you want to insert it. And it does not change the original list, it inserts something at the specified index. So I want pair at the first index. So first index is melon. So after kiwi, this is the first index. Here pair will appear. So this will become kiwi, pear, melon, and cherry. Let's check this out. See kiwi, pear, melon, and cherry. But then if you have used append, then after the whole list at the last, cherry will be added. So let's check append also. See kiwi, pear, melon, cherry, and then strawberry. Now we can also remove items. So we remove pair. Using the remove keyword, you can just specify which item to remove and it will remove that item. See, pair is removed. Using pop. Pop is similar to append. As append adds to the end of the list, pop also deletes from the end of the list. So let's see. See, strawberry was popped. If you run this again, cherry will be popped. Let's run this again. See, cherry is popped. Once more, if you run this, melon will be popped, but that we won't have any good list to work on. So let's not pop it again. We have del and clear also. So let's see what del does. See, after del, only melon is left. So del deletes whatever you have specified. So I have specified 0th index, kiwi. If I delete kiwi, it will only delete the specified index. But clear, what clear does? Clear deletes everything. So if I have the bigger, before the removal, if I just run this section again and get my original list, and then just have remove is done using 10, using clear. Okay, print original list fruits after clear fruits. See, clear originally this was my list because I've again ran it. So in this list, after we have used clear, the whole list has been clear and you are left with the empty list, right? Now we can sort lists. So we have two lists with numbers and words. So let's just sort it. Ascending sort is generally done by list.sort, where it's list name dot sort. It sorts the list in place, so you don't have to assign it again to the variable. You just get the sorted list. So you get 1, 2, 3, 4, 1, 2, 5, 5, 6, 9, which was 5, 2, 9, 1, 5, 6, whatever. If you say reverse equal to true, it will be sorted in descending order. See, it is sorted in descending order. If you want it to be case insensitive, you have to say key is string dot lower. So what it does is there is a key for sorting, right? So you specifically the key is now string dot lower means all the strings inside this list will be first converted into lowercase and then they'll be sorted out. If I don't mention string dot lower, what happens is in this case I don't think it will happen. Yeah. So this is case insensitive. This is case sensitive sort actually because I have removed this. Uh, let's just sort it again. Let's sort. Mm, let's have something banana, apple, cherry, cherry, small, apple. Now let's run this. See, when case sensitive sort is done, when case sensitive sort is done, banana comes first because it's a capital B and its ASCII value is lower. But if you want a case insensitive sort, you have to mention the key. So this is what the key is. Let's just copy it. Let's just Control C. Copy it. Count, comment it. Delete this one. And this is case insensitive sort. See, when case insensitive sort is done, what happens is these all three are changed into first string dot lower. So apple, banana, and cherry are converted to small. I mean, thanks, Shaheen, for your support. Really means a lot. Hope that you will stick by to the stream and learn something new. Really good to see people joining in. Uh, so yeah, as I was explaining, first it converts a string to lowercase and then it sorts. So this is a very important thing, mentioning the key. Now reverse numbers you also can do without this using this reverse dot equal to true, or you can just use a reverse keyword. There is a keyword called reverse. So if you say numbers dot reverse, it will just reverse the list. Okay. Let, this reverse dot true gives you in a descending order, but numbers dot reverse just reverses the list. So let us just explain this here because first the numbers are already getting executed as here. Let us take numbers and then we do this. Then we do this. And then we do this. But let's just. Mhm, mhm. So see, reverse numbers will give you just the reverse. 6, 5, 1, 9, 2, 5. It's not sorted. It's just reversing the list. Sorted by length. So here I've mentioned the key as length. Similar to here how I've mentioned key as lowercase things. So here the key is mentioned as length. So sorted by length, we get words. So the smallest word is apple. If we add something else, let's say we add what can we add here? Let's say dog. Right, dog has the smallest length. See, dog comes first because it's sorting by length. It's not sorting by the character. It's sorting by length. So dog has 3, apple is 5, banana is I think 6, and cherry is also 6. So if they have the same length, then it will sort by ASCII characters, right? So you can copy list using just copy. So this gives us a new list. You can just have a copy list and say numbers dot copy and numbers will be copied. So 9, 6, 5, 5, 2, 1, which was basically where is actual numbers? This thing, yeah, numbers was yeah. See, last, let's just print numbers also. Print, because numbers, you know, numbers have gone through a transformation. I mean, numbers have been reversed, number have been this and that. So we'll just print the original. Let's see numbers. Yeah. So numbers is this, and the copied list is just the same. We can join lists. So let's see how we can just use plus or use extend. So using extend adds a list to the end of another list. So we have list one. List one is ABC. List two is 1, 2, 3. We can just use plus. It gives us ABC 1, 2, 3. We can also use extend. It gives us ABC 1, 2, 3. Right. One more important topic about lists are list comprehensions that we'll touch when we go to further topics. So after control flow, you can better understand list comprehension. We'll now go into tuples. Let me just check. Yes, list is done. I will go into tuples. So tuples are also a collection, but they are ordered, they are unchangeable, and they also allow duplicate values. See, everything that is ordered will allow duplicate values because the duplicate values are then accessed using their indexes. Right. One thing about tuples is they are unchangeable. So once you create it, you cannot change it. Similar to lists, lists are expressed within third brackets. Tuples are expressed within first brackets, and you also have a tuple constructor similar to the list constructor. So let's just check it. See, apple, banana, cherry, length is 3, and using constructor mango, orange, and grape, we have generated. Right. Similar to list, indexing is exactly the same. Checking an item is exactly the same. So we'll just run it. You just play with this block whenever you get the time. I will upload this code. You can just see for a moment, and then we can just proceed. So now comes the question of immutability. Since you cannot change tuples, how do you add or remove something to a tuple? Here is where the typecasting concept comes in. Remember, we can change int to a float, float to a int. You can change type. In collections also, this is possible. So what we do is we first take the tuple, we convert it into a list, and since list is mutable, we add or remove or change things in the list, and then we convert the list back to a tuple. So we get a tuple, change it to list, do our work, and then come back to tuple. See, after changing, we get apple, blueberry, cherry. Because we've changed first index to blueberry. Instead of banana, we now have blueberry. So how do you add items? You can add items using concatenation. There is no, inbuilt function to add items. So you can just concatenate them. How do you concatenate? Just as joining list. We use plus to join list. So similarly, we make another tuple, which is a pair, and just add to the original list, original tuple. Similarly, removing items. So you have to use the list methodology. You convert it into a list and then remove it. But using del, similar to everything, using del deletes the whole tuple. As del deleted, you can, I mean, in tuples, del is the keyword to delete the whole tuple. When it was in list, del was not the keyword to delete the whole list. It was a keyword to, you can specify that I need these items deleted. For clearing the whole list, we used clear. But in tuple, we can use del to delete the tuple entirely. So let's just see this code blocks in action. We've changed it into list, and then we've removed the apple from the list, and then we've changed it into a tuple. So apple is removed from here. When you use del, see, this fruits will cause an error. You can uncomment this and check it in your own time. So printing fruits will cause an error. No, screen not showing right. Mhm. Man, I hate OBS. OBS does this glitchy things. Hopefully, you have heard the content. I don't want to repeat the code blocks. It's very similar to strings. If you have heard strings, you will know. Mm, Really sorry about that. I will keep in check. I don't have my second monitor, so it's really hard to keep a check. Hopefully, you've heard it. I will give you the code block. You can work out the codes on your own and you can see. I'll just give you a quick run through about what we have been talking all this time. Yes, obvious glitches, man. What can I say? So this was list where we can make list using third brackets or the list constructor. We can access items similar to strings. We can check using the in keyword. You can change items like this by specifying the index, by specifying a range of indexes. You can use insert to have a item inserted at a specific index. You can use append to item added to the end. You can remove a specific item by using the remove keyword. You can pop so that the last item gets popped. You can use del keyword with a specific index to delete the specific index. You can use clear to delete the whole list. You can sort list using sort. You can sort them ascending using sort. You can sort them descending using reverse equal to true. You can do case sensitive sort. You can do case insensitive sort by mentioning string dot lower. You can do custom sort with key by mentioning the key length. So here we have mentioned length and it is custom sorting because according to the length, not according to the characters. You can have the reverse using the reverse keyword. You can do copy of a list using the copy keyword. You can join list using plus, I mean adding or extend, which adds the list to the end of it, one list to the end of another list. Similarly, tuples you can do. So we're here. Looping also you can do in tuples. So if there is an item in fruit, just print the item. See, apple, banana, cherry, and banana is there, right? Adding tuples, as I said, you have to make two tuples and then add them, right? Because they are once created, they cannot be changed. See, adds unpacking tuples. So there, this is a very interesting thing. When you have a tuple and it has suppose n number of items, you can assign n variables and point it to the tuple, and each variable will be assigned to the I mean, the nth variable will be assigned to the nth item. So see, it has three variables. We have three items. We have three variables. So let's see. See, if you don't want all or mention all variables but want specific variables, you can just give those variables and then use a star keyword and then mark it. So this rest thing will be all the rest of the parts. This will be rest. Okay. Print type. So this will come as a list. So it has been unpacked into A. A is 1, B is 2, and rest is this. This will be a list. So these are two tuple methods. There is count, which counts the total number of elements in a tuple. And then there is index, which gives you in which index the particular item is present. Set, similar to all this, but set is unordered, unchangeable, and unindexed. Since it's unordered, you cannot have duplicate items in a set. Similar to the set theory in maths, you cannot have duplicate items in a set. So sets are explained by curly braces. See, in spite of being unchangeable, set have add and remove methods. You can change it, but you can add and remove. So that's a really good part of sets. So sets are generally used for storing IDs. I mean, you don't. IDs are like roll numbers, right? Instead of being four on, in spite of being four on rugs in a class, you want each of them to have a specific roll number. So you can just say roll number 10. You cannot assign roll number 10 to 10 people. So that's where sets come in. So they are always unique, right? They are always unique. So you just check how to clear, copy, and then uh, similar to maths, set has all the functions a set does: union, intersection, difference, and all of them are present in two different ways. One gives you the one, if you just say difference, it will give you the difference. If you say difference update, it will do the difference and update the set. So let's see it here. Set 1 is apple, banana, cherry. Set 2 is banana, kiwi. The difference of set 1 and set 2 would be apple and cherry. Now, this is difference. We can just say set dot difference or set 1 minus set 2. But difference update, what happens in difference update? So after the difference, if you can see print set 1, set 1 is not updated. Okay, set 1 is the original set 1. If you only use difference, set 1 is the original set 1. But after difference update, set 1 is updated to set 1 minus set 2. Similar to discard, you discard is basically just like remove in list. So you can just see, yeah, we have discarded 2, so 2 is removed. Intersection is also similar. Using intersection, you can use and, or you can just use the intersection keyword. And intersection update, you can check if two lists are disjoint. Basically, what disjoint is two lists have nothing in common. So you can just check if they are disjoint. Yes, they are disjoint because these two have nothing in common. You can check if one list is a subset of another. Using comparison operators also, using the is subset also. You can check the superset thing. You can pop. Pop is similar to the list pop. It removes the last item of a list. So see, sorry, in list, pop removes the first item of a list. In list, pop removes the last item of the list. In set, pop removes the first item of the list. So we can also have symmetric difference. See, and symmetric difference update is also there. Union is also there. Only update is also there. So what only update does is it adds the list, right? Now, one of the most used after list, or I think similar to list, is dictionary. Tuples and sets are generally not very widely used. They are used in very specific cases, where lists and dictionaries are very widely used in every case. So dictionary is ordered, changeable, and does not allow duplicates. It's a key value pair. So it's not how it is ordered. It has a key and it has a value corresponding to that key. As you can see below, person is a dictionary where the key is name and the value of name is Alice. A key is age and the value of the age is 25. So we define it like this. So a key has to be there is a specific naming structure for key, but a value can be anything. It can be a list, it can be a string, it can be a number. So you can also copy dictionaries. You can also make a dictionary using a keys. So you mentioned a set of keys like A, B, C, and you have a default value to assign to all of them. You say new dictionary from keys from a default value. So A, B, and C all are assigned a default value. For accessing, you have get. Uh, in get, you can get what is the value of that specific key you have mentioned. If you mention a key and then there is no, I mean, the key is not in there, you can mention something to be printed out that, yeah, this is not found or this does not exist. So that will get printed out. Since here I've mentioned not found, so not found is getting printed out since salary is not there in the dictionary. You can see all the items in the dictionary. So the items are in a key value pair. So name Alice, age 25, city New York. You can only see the keys in dictionary that is using the keys keyword. So the keys are name, age, and city. You can only see the values in the dictionary, which is the values keyword, which is Alice, 25, and New York. So you can set default. Mhm. You can add something using dot set default and then the key value pair. So you see after set default, it gets updated to name, age, city, and salary is 50,000. You can just copy a list and you can update a list using a key value pair, or you can just give another dictionary. So it will just update that part. So I have updated the age key to 30 and the country is a new key which will be added and it is set to USA. So after update, it gives us that. Removing items similar to every other thing. You have you have pop item. So in pop, you have to mention the key. In pop item, you have to mention, you don't have to mention anything. The last item gets pop. Clear clears the whole list, whole dictionary. So that's it. Yep. That's it for collections. We'll just take a break and we'll just come back in 5 minutes. Okay, guys, data types is done. Let's move into a really small but interesting topic, which is operators. Let's just change the screen. Operators are visible. I'll just confirm once because OBS has been glitching and all my screens have been lacking like that. Just give me a second. There is delay on, so I have to check on my phone. Yep, it's visible. Let me turn on the camera also. Okay, let's go into it. So there are multiple types of operators in Python. Let me just tell you what they are first. OPS will be the type of thing. So all the types of operators are there are arithmetic operators for performing operations on numbers. There are assignment operators for assigning a particular value to a variable or checking if a particular value is assigned to a variable. Comparison operators for the second part. Comparison operators is there to compare two variables or to compare two values or to see if one thing is greater than another. Basically, basic comparison. Logical operators we use and we use or if you know basic logical reasoning. I mean truth tables and stuff, so you know what logical operators are. There are identity operators, which we'll see. There are membership operators, and there are bitwise operators. So remember these operators sometime before. So we'll see all that. Uh, for the basic math arithmetic operators, let's just not waste much time. We'll just see. We have addition, subtraction, multiplication, division, and then we have modulus, exponentiation, and flow division. So what modulus is and what flow division is are two important things. Division gives us a float because obviously when you divide something such as 10 by 3, you will get something like 3.33, which is a float. Modulus is the remainder. So when you divide 10 by 3, the remainder is 1. So it gives you the remainder. And floor division gives you the floor of the quotient. So remember when I explained floor is basically the lowest integer to a particular number, like lowest integer, and ceiling was the closest highest integer. So floor division is expressed by double backslash, and modulus is expressed by a percentage sign. So let's just see. Here x is 10, y is 3. We add them, we get 13. We subtract them, we get 7. We multiply them, we get 30. We divide them, we get 3.3333. We modulo them. So 10 by 3 leaves the remainder of 1. So we get the remainder 1. We use exponentiation, which is 10 to the power of 3, which is expressed as double stars, double asterisks. We get 1000. And then we have flow division, which we get 3. So assignment is basically assigning a particular value to a variable. So when we use this kind of assignment operators, some arithmetic and then an assignment operator, that means a plus equal to 3 is same as a equal to a plus 3. So this part is written as a plus equals. Similarly, this part is written as a minus equals. This is a star equals. So basically, whatever operator is there, that operator will perform the operation on the variable and then the number. So let's just print it out and check. Initially a is 5. When you do plus equal to 3, 5 plus 3 is done, so it gets 8. When you go minus equal to 2, 8 minus 2 is done, because a minus equal to 2 means a equal to a minus 2. So 8 minus 2 gets 6. Star equal to 4. Similarly 6 into 4, 24. Flow division with 3, 24. Flow division with 3 is 28. Normal division with 3 is also 28. Exponential to 2, 8 square, we get 8 to the power 2, we get 64. There is something called a walrus operator. Uh, so how do I explain walrus operator? Okay, let me just see what is a good way to explain the walrus operator so that. So it's basically like updating a variable. Okay. Uh, so it allows you to add a value to a variable within an expression. So x is to equal to 7 adds the value 7 to x. When I mean walrus operator is a very new concept and it's not used as much, so if you want you can skip it for now, but it is good to know that there is something called a walrus operator. You generally use this in control flow, like in loops, so that you don't have to do the calculation again and again. It just assigns itself. For comparison, we have equals, not equals is represented like this: greater, less, greater equal to, or less equal to. And they all give us Boolean values. So x is 10, y is 20, x equal to y, false. Not equal to y is true, x is greater than y is false, x is less than y is true, x is greater equal to y is false, less equal to y is true. If we change the values to 30 and 20, we'll get different values. See, if we change it to 20 and 20, we get different values. So you can just play around with it. Logical, using and, or, and not. These are the three keywords. So, and when and gives it, these also gives true. I mean, these also work on booleans and give us boolean values. So when they work, and works if both are true, then it gives a true, or works if at least one is true, then it gives a true, and not this reverses the true or false value. So here we have x is true, y is false. So x and y, since one is false, it will give false. X or y, since at least one is true, it is giving true. Not x, this reverses the value of x. So true becomes false. That's all for the logical operators. Now we can go ahead and check the identity operators. So identity operator is these two keywords, is and is not. So if something, if two value matches, if two variables have the same values, or if they are the same object, not the same values, they are the same object. So if like this, A is 1, 2, 3, and B is A, B is not 1, 2, 3, B is A, but C is not A, C is a different 1, 2, 3. So these 1, 2, 3 are stored in memories, right? So you have to point to them. If you know pointers concept in C, you will know that they are stored in memory and we have to point to them. So B is pointing to A. So B and A are the same thing. So let me just explain it in bit detail. I'll just go into my whiteboard and explain it. Just give me a second. So let me just go to the whiteboard. Is the whiteboard visible? It's not visible. See, this thing is terribly shitty. Hopefully it's visible now. OBS keeps on glitching, like crazy glitching. So you just have to have an external screen or something to, just know that. Oh. So suppose I have A. Uh, I have something called A, which is has some value, right? So in the computer memory, A is stored somewhere here. We mark B equal to A. So B is stored here. B is pointing to A. So A is pointing to a particular object. And since B is equal to A, B is also pointing to that object. So A and B are necessarily the same object. A and B necessarily are the same object. But C is pointing to a different object. Their values might be same. Their values might be same. Values might be same. But they are different objects in memory. So when you use is, if they are the same object, it gives true. When you use is not, just the opposite. If they are the different object, it gives true. Let's just see it in action. Let's just see it in code. You will just understand. It's a very easy concept. So B is A. Now A is B. Basically, it's like English comprehension. If A and B are the same thing, A is B, true. If A and C are not the same thing, A is not C, it's true. If you say A is C, it will give false. See, A is C gives false. Gives false. Membership operator, as I said during list, in and not in. So if it is in fruits, it will give true. If it's not in fruits, it will give true again. I mean, basically, if it's in there, it will give true. If it's not in there, then it will give true. So if I say apple not in fruits, it will give false because apple is in fruits. See, bitwise operator. This was we were discussing yesterday. So see, 6 and 3, 6 is represented as 110. Exactly the same example told you. In binary, you have to represent it. 3 is represented as 011. When you use AND, so 0 and 1 gives 0, 1 and 1 gives 1, and 1 and 0 gives 0. So it will give 2. Similarly, or you can do, so or 0 and 1 gives 1, 1 and 1 gives 1, 1 and 0 gives 1. So it will become 7. 1 is 7. So bitwise operator is like that. Right shift and left shift is basically shifting the bits. So when we do 110 and shift it to the left by 2 bits, we get 110 and then 2 more bits, 00. Right? So it's 24. If we shift it 1 bit to the right, it's 011 and it gets 3. So one bit is shifted to the right. Right? Let me just explain this to the. Uh, mhm. So if we have 110 and we shift 1 bit to the right, so this one will come here, this one will go here, this 0 will go somewhere. So 1 1 and then you have to fill, there is a blank, right? So what you fill blank with, just put 0. So it becomes this, right? So this is how right shift works. Left shift works exactly the opposite way. So you 110 is left shifted by 2 bits. So you get 1 2. So there are total 1 2 3 4 5 bits. 1 2 3 4 5. This one is shifted here. This one is shifted here. This 0 is shifted here. What we fill with the blank bits? 0 0. So what we get here is 24. Okay. This is how it works. Left shift and right shift. Very easy concept. Very simple concept. We're still in very simple waters. So this is done bitwise, and that's operators for you all. That is operators. Hopefully, operators you've understood. Why is Python bugging out again? Just hold on a second, guys. Python is bugging out again. So let's check him out. Now we move on to a very interesting part called control flow. Control flow. I have operators also. So this is something you have to know. Operator precedence, which describes the order in which operations are performed. So if you have multiple operators in a single evaluation or single expression, so there must be an order in which the operators are done. If there are, you see this third instance, so you can have all these three. So how will you know which one of these three will be evaluated first? If they have the same precedence, evaluated from left to right. So this is a list. This you have to remember. I will add it in the. Let's see if I can add it in the. Here, cannot. Nope, I cannot paste it here. I'll add it in a README file. Let me just add a README file. New file readme.md operator precedence md. We need to have that image saved, right? Okay, let me just save that image then. I will provide you that image. Okay. You don't need to worry. I think I have there in the books. If, let's download image. Open Python. Okay, let's move on with control flow. I will add that. I will add that as soon as I get the time. As soon as Python thinks that it doesn't want to be slow anymore. OBS really messes things up. That's what I've been understanding. So yeah, I hope you can see the control flow part. Once. Visible. So, what is control flow? It's the order in which instructions are executed in a program. So, as I said, it's an interpreted language. So, first line you write, first line is executed. Second line you write, second line is executed. But what if you wanted to skip the first line? Or what if you wanted to print the second line first? Or if there is a condition that if this condition is fulfilled, then only print the first line. If this condition is not fulfilled, print the second line and something like that. So that's where control flow comes in. So they are divided into two parts, conditionals and loops. And they allow the program to make a decision. Loops, so that's conditional. So you give a condition and then decision is made based on that condition. Repeat an action, so that's loops. So and choose different paths. So you can either have a conditional inside a loop or a loop inside a conditional, and that's how you define a path. So this is going to be very useful. Moving on. And this is completely based on the data provided and the logic you have put. So these are the objectives. Let's just see why it's important. So it's important because you can build dynamic programs. You just not programs that just have 5 lines and 5 lines are executing standardly. You can have dynamic programs. You can have particular conditions. Like suppose if you are designing a program that says that are you eligible to vote or not. So you can just have a condition that if he's over 18 years of age in India, if he's over 18 years of age, then say that the program will say yes, you are eligible to vote. If he's below 18 years of age, the program will say no, you are not eligible to vote yet. So that's dynamic programming. And without control flow, they will execute in a fixed sequence. With control flow, you have decision, you have branches, you can make more changes in the code, and the data can be processed much more efficiently because the data does not have to go through everything. The data only goes through only those parts which the conditions are met. So if I had to check individually that yeah, he is 1 year of age, he is 2 year of age, he is 3 year of age, he is 4 year of age, or just use a comparison like yeah, if you are this year of age you cannot vote, but rather than that I just give yeah, if you're 18 you can vote, if you're under 18 you cannot vote. So it's more flexible, it's more efficient, it's more readable, and it's adaptable to real world problems. That's the most important part. It's adaptable to real world problems. Okay, so let's just not waste time here. Let's just quickly move on to the code. And yeah, let me just insert the image that I've downloaded. Image, browse, let's see, downloads. Hmm, where is image? It's just open my finder. Let me just do something real quick. Let me pick the image. Paste. Okay. Good. This is the correct path I wanted to. Just copy path. It's the path. I hope this is the correct path, or I'll just add it again. So these are the basics. Let's check what. So conditionals basically work on true and false values. So if you have a condition, it will only work if one is true, one is false, or if some are true, some are false. So that's how conditions work, right? So let's see basic truthy and false values. So zero is considered as false. We've seen this in Boolean, right? Just to try to remember, we've seen this in Boolean. One is true, empty string is false, non-empty string is true, empty list is false, non-empty list is true. This is how it goes. Just let me going to the if else part. This is the most basic conditions. So we have if, elif, and else. These are three keywords. So if checks for something, elif gives us another condition to check. So x is 10, right? So if x greater than 15, we execute this block. If or I mean, you just don't have a if this is true, then say yes. If this is not true, then say no. You have multiple things. If this is true, then check for this. Or if this is true, then say yes. If this is not true, then check for this. If this is also not true, then check for this. So you have multiple things. And else is the final condition. Like if anything is not working in the if statements, then just say else. Just say something random. So if x is greater than 15, this code block will be executed. So see, in conditionals or in loops, we have this indentation to just specify what will be printed. If I just move this code block just even a little. See, this gives us error, red squiggly errors. So you have to have indentation perfect. Not too much indentation will also disturb it. Now, see, yeah. So x, if x equal to 10, then another condition. If x is greater than 15, it will say x is greater than 15. If x is equal to 10, then it will say x is equal to 10. Else, if both these conditions are unsatisfied, then it will say that x is less than 15 and it is also not 10. So if we just keep it 100, if we keep it 101 and see x is greater than 15, if we just keep it 1 and see x is less than 15 and not 10. I have multiple examples in this control flow page, so you can work out with those. I'll just give one example of each and then move on. So while is something, here we'll run three things: while, break, and continue. Also while with else. So while is something that you say that while this thing is true, this thing works, count is zero, right? While this thing is true, you print a code block and you update that variable. So while a variable has some properties, you print that code block and you just update the variable properties, right? So while count is less than 3, so count is 0 now, we print count and then count is plus 1. Let me just explain it in easier terms on paper, I mean on the whiteboard. So we say this variable called count, right? So it is first it is 0. So while count is less than 3, so what values can count at? 0, 1 and 2. These three values count can have. Print high. So first and then count plus equal to 1, which basically means count equal to count plus 1. So first it goes into this block. It says that it first it checks if count is less than 3. So now count is 0, it's less than 3. It works. So it goes into this block. It prints high. Now count is no more 0. It's now transferred to 1. Count is count plus 1. Again it checks count is less than 3 to 1 is less than 3. It again prints high. Again count is updated. Now it's no longer 1, it's 2. Again, it checks if count is less than 3. Yes, it is less than 3. So it will print high again. And then count is increased by 1. So it becomes 3. Now it will check if count is less than 3. It's not less than 3. So this execution is stopped and it will just skip. What break does is, so what break does is, suppose you've written while count less than 3, print high. But if count equal to 2, break, else count plus equal to 1. So for 0, it will work high. For 1, it will work high. For true, what happens when count is 2? It goes to this block. It sees the break statement. So break, what it does is it forcibly takes this whole loop. It forcibly exits this whole loop. Okay, it forcibly exits the whole loop. Similar to that, we have continue. Similar to that, we have continue, which skips that particular iteration. So when it's 2, it will skip. So 0 will work, 1 will work. When it's 2, it will skip in case of continue, right? And else is when everything is done, then there is a else block that, yeah, everything is done. So just print that, okay. Or not everything is done. When any cases of while does not fulfill, then there is else. Similar to if. If any cases and if there is not fulfilled, there is else. So similar to if, the while is also having an else. We use else with while, but very, very rarely. So let's just move to the code now and let's just duke it out. See, in the first thing, count. initialized to 0, less than 3, we just print count. So 0 is printed, 1 is printed, 2 is printed, it gets equal to 3, it skips. In the next case, we have a break. So we break at exact 3. We break at 3, right? So after 3, the whole loop is exited. See, 0, 1, 2, breaking at 3. It breaks at 3. Have we not included? Okay, let me just break it down so it's better visible. See, 0, 1, and 2. In case of normal while, we break, we have breaking at 3 and then it stops executing. With continue, we just skip this value, right? See, 1 is printed, we are skipping 2. We're skipping 2, we are not printing. We are not printing 2. 3 is printed, 4 is printed, 5 is printed. Okay. In case of else, see, if it works, it works, and then there is else statement that yeah, loop has ended. See, 0, 1, and 2, and then else statement executes that yeah, loop has ended. Similarly, we have for. We have break statements in for also, just similar to while, but while for is works for a range, for works for a range of numbers, right? So when while works for until it's true and you have to update, for iterates itself. So one iteration is done, it updates the number itself. You don't have to manually update it, as in while you have to manually update it, right? In for you don't have to manually update the numbers. Let's just take it there. Let's just see 0, 1, 2, 3, 4 in range 5. So range is a keyword similar to, so it starts from 0, or you can have a starting offset, right? If we give 5 to 10, see it starts from starting offset and goes up to the ending offset minus 1. So 5, 6, 7, 8, 9. Similarly here, if you don't, similar to slicing, right? If you don't have a starting offset, it will just consider starting at 0. So breaking at 2. So it breaks at 2. See, there is a break statement. So if I modulo 2 equal 0, that means if remainder when I is divided by 2, if remainder is 0, basically even number, it will skip. So it will skip 0, then odd number is printed. It will skip 2, then 1 is, it will print 1. It will skip 2, it will print 3, it will skip 4. And else works the same, right? For loop ended without break. These are some other styles you can check. I have included it. You can just go ahead and play with the. Yeah, you can just check this out. So there is zip, there is enumerate. So what zip does is when you take two, you take two sequences and you zip with them. So it combines the sequences. So Alice is assigned 85, Bob is assigned 92, Charlie is assigned 78. If you add something like Douglas. See, since Douglas doesn't have a corresponding score, Douglas will not be added in the zip. If we have a corresponding score for Douglas, say 26, Douglas will be added. But if you remove Douglas and then add 26, see, 26 is not added. So that's how it works. Zip corresponds it. It makes it similar to a dictionary structure. You have range. Obviously, you have range. You have enumerate. Enumerate basically adds. So if you just take it, enumerate and zip are very two interesting functions. So that's why I'm explaining it. The rest you can just work out. Something you have to stimulate your mind also. Everything can't be spoon fed, as they say. So enumerate basically takes a sequence and adds a number, like as indexing. It does the indexing. So if you just see, so it has zero for index from a fruit in enumerate. It always starts indexing from zero, right? You enumerate, you pass in a sequence. So apple is considered zero. It is mapped to zero. Banana is mapped to one. Cherry is mapped to two, and orange is mapped to three. This is how control flow works. So now we go ahead and get into functions. Suppose, let me just set the context for functions. Suppose you have to print, you have five friends and you have to print their names and you have to say hello to all of them. So how will you say F, hello, Sagar, not like this. Hello, never mind. Hello, Sagar, we'll say print, uh, hello, Sham, print, hello, hello, Sham. See, so to print three friends' name, you have to print thrice. So this is a repetitive task, right? So this in this case, it's a simple print task, but generally we have to do multiple codes, right? Uh, we have to print multiple stuff, or we have to do a basic action on a code, and we have to do it on different objects. So we can't just continue writing code like for this. Let me just say. Um, Suppose we are simulating a die roll, right? So we say for I in range 1 comma 7 because 1 to 6 is there. Uh, Print I, not print I. How to explain this? Let me see if I can find a better suited explanation. Okay. Let's see if this helps us understand the point. So let's say we have this. If we have this big if else block, right? So we have something called color. If color is red. So this is a traffic light, right? So you are at a traffic light, and you have made a traffic light, and every 30 seconds you print out what the status of the traffic light is, right? So what you have to do, we have to just for now color equal to red, color red, print stop elif color equal green, print print go, comparison is done here. Else color equal to yellow, print wait. So Imagine, yeah. Imagine this. This is the traffic light code, and every 30 seconds the color is changing. So what you have to do, you have to write code every 30 seconds. Like you have to write this if block every 30 seconds, or you need to change it at particular intervals of time, or you need to use it at particular intervals of time. So every time you need to use this traffic signal, you have to write that in the code that yeah, the color is this and this is that. So what if you put that in a block, in a reusable code block, and whenever you want to use it, you just call the code block that yeah, come code block, come here, you execute this and just give me the result. How you're giving me, I don't want to know. You just work it out and give me the result. So that's what a function does. It's a reusable code block. How is the function made? So it's, let me just explain the legit, I mean the actual definition. So a piece of code separate from all others that can take any number and type of input parameters and give any number and type of output results. So there are two steps to a function. You have to define a function and you have to call a function. Define is done by using the def keyword. You write the function, use the colon, and then use indentation and do the work. And calling is done simply by calling the function. If it has a parameter, then you use the function parameter. If it does not have a parameter, then you don't need to pass parameters. We'll talk about parameters right now. So there are arguments, right? So you don't want just a function to, in this case, we wanted the function to take in the color and then print it. So here we have a name, and then this name is passed on here. So when you say greet Emil, so Emil goes here, and then this thing is printed Emil hello. Similarly, Tobias is the thing you're passing on to here. So it goes here, and then Tobias hello. Linus hello. This is how it works. You can obviously have multiple arguments. So Emil refness, you just want to say full, how to write a full name. You have first name, last name, you add them with a space. So you say Emil refness. Now what happens is if something is expecting two things, if I'm hungry and I'm expecting that you give me two pieces of, you know, two pieces of chicken and you give me one piece of chicken, I'll be very sad. I will be very angry. I will not eat because I'm hungry and you have promised me two pieces of chicken. So similarly, full name is been promised two pieces of argument, but you are passing only one argument. So what full name does is, see, it requires one more positional argument, L name. We also have arbitrary argument, args. So what arbitrary argument does is, so if just print names, you can just see. So arbitrary argument passes everything, every argument is passed into it as a tuple. And then it does the, see, star args. So you have to just star and then have the argument, collects argument as a tuple. So Emil, Tobias, Linus, the youngest child is always the second one, or the last one. So you just say last one. The last, I mean, if you are writing it in a way that you are passing it by age, then we can obviously say the last one is the youngest child. So you just print it, and Linus here is the last one, so he is the youngest child. So something called keyword arguments. So child three, you can just specify. So if you want to, pass on child three first, child two, child one, you always have to remember that yeah, this was my order, that is how I have to return. But when you have a small function and you have to use it on, when you have a large function and you have to use it regularly and it has multiple parameters, so you don't tend to remember that what are the parameters. So you just mention it. The child one I'm mentioning, I remember there was a child one, but in which position I don't remember. If you don't mention it, what happens is, if I just write children, Emil, Tobias, and Linus, see, the youngest child comes out to be Emil, but Emil is child one. Why it is happening? Because when we don't add anything, Emil is directly mapped to child three and gets printed. So we can just map it like this. So similarly to args, we have quarks, which basically it is arbitrary. So these are fixed. See, these are fixed, but this is arbitrary. So what in quarks, what happens? It's keyword arguments. So keyword argument, you know how it was presented. So when we use arbitrary keyword argument, it is passed as a dictionary. So we can just, and we use double stars for it. So we use print kids. See, we have passed in keyword arguments. So first name Tobias, last name Refness. We get F name Tobias and N name Refness as dictionary, and then we can work on the dictionary. We can have default values for parameters. So sometimes, you just have to have default values. So you don't know a value. So what will you pass? You cannot just, so you fix it that, yeah, there is someone, if someone is, you print which country someone is from, but by default we assume that that person is from Norway. If you specify that it's Sweden, then country is Sweden. But if you don't specify anything, then there has to be a country, right? Or it will give error. So then the country chooses Norway. So when we specify Sweden, the country is Sweden. When you specify India, the country is India. When you don't specify anything, it takes the default value, which is Norway. And when you specify Brazil, it takes Brazil. You can pass a list as an argument. So food here is list, so list, all list operations are done here, so we can just print food and see argument is a list. Something, a function can have a return value. It does not need to be only printing something, it can return you something. So multiply by 5 returns you 5 times the argument if passed. So first multiply by 5 returns you 15, second one returns you 25 because 5 times 5. So that is what basic arguments, what basic functions are. Uh, that is all the theory you need to know. As we proceed on further, when we get to oops, this functions thing will get much more clearer to you. For now, that is it. If you have anything, any doubts, just post it in the comment section, or maybe if you are really sorry, Harish, if you're still watching, I'm really sorry, but my screens, I don't have my screen set up properly, so I could not see the comments. It is live. I will try to, mm, so if you have any questions, if you want to ask something, you can just put it in the comments. I will try my best to reply or make a small video on that. Really sorry about that, Harish. It's not a recording. I don't have my screen set up. So probably by the end of next month or by the middle of next month, I will have my second screen setup, and that will help us, that will help me a lot to, check the chat, check the queries, check if the stream is running correctly. Really sorry for that, but till then, I would say please kind of bear with me. I will also have like extra sessions if you want. If you want, I can, just interact with you guys, whatever, wherever you have issues, I can write a code, explain it to you. But sorry for that. Harish, you are still watching. I'm really sorry. But that's all for now. So maybe we meet tomorrow or day after tomorrow. And yeah, have a great night, guys. Sometimes these technical difficulties are too much to take. Lost a good viewer. It was painful. Um, Harish, if you are watching this later, I'm really sorry for that. Uh, really sorry for that. I had my chat, it's really hard to concentrate on chat and PPT and the code, everything while on a single screen. And you also have to manage the OBS, and OBS is being bad today. It's glitching a lot. Not today only. Every day OBS is glitching a lot. So if you're still watching, you can just drop a hi. You can ask your doubt. If you're not, I think we're good to end the stream. I will add the GitHub link again in the description or maybe in the channel link. Uh, Let me see if I've left anything in functions. Just give me a second. Let me check my notes. Okay, something very important in functions. When you are writing a function, you will not write something like multiply by five or multiply by six. You are writing for a bigger piece of code. In real world, you are writing for a bigger piece of code, and it's probable that that piece of code will be worked on by multiple people, or that thing will be used by multiple people, and they want to check what kind of code it's using, and they want to see that how it's using that, how it's utilizing that. So there's something called a doc string, which is basically documentation of a function. So how a docstring is written, let me just show you in Google how a docstring is written. Uh, Docstring. Docstring is basically a documentation of a function. So docstring is written, how do I explain? Yes, docstring is written like that. So you say my function, and then there is a docstring. So docstring defines what parameters the function takes. Just see. Documentation with Python. So documentation within the module. Hi Sumanto, you were very early, I would say. We are just about to end the stream. Still, if you want, you can check the video. So this is the documentation part. So there should be a doc string for every function. This is a way to write good code, and it helps the other people who are reading a code or exploring your code to really understand why you have used a particular function, what parameters the function takes, how the function returns a value, what the function does, where the function is used. These all kind of things is are included in a proper doc string. So if you just go and see Python documentation, I think we can get some doctrines for some functions. Let's see if there is a docstring for any functions. See, this thing. This thing is a docstring. This thing. So fib n is a Fibonacci series up to n, and the docstring says that what the function does. It prints a Fibonacci series up to n. So this is how we define a function. If you want, you can read on Python documentation. It's the best kind of reading material you can get. And yeah, that's all for today. Let's end the stream and